Systems of nonlinear equations. Our objective for this video lecture: solve a system of nonlinear equations using substitution, elimination, and graphing. Now, we've spent a lot of time talking about solving a system of linear equations, and so we're familiar with substitution, elimination, and graphing to find our solutions. One thing you'll note here is I've not included matrices because nonlinear equations cannot be solved using matrices. Matrices only apply to linear equations. All right, let's recall what we know. We know what a nonlinear equation is. A nonlinear equation is an equation that is not a straight line when it is graphed. So we're talking about quadratics, that graph as parabolas, maybe cubic equations, equations that graph as curves. You can do circles even. The key to the fact that this is a system of nonlinear equations is that a nonlinear system may have more than one solution. So I want to be aware of that. When we have a linear system, lines can only cross in one point or be on top of one another. Okay, but nonlinear system, curves can intersect at numerous locations. So we want to be aware that we might have more than one solution. All right, example 1. Let's solve this system here. Y equals x squared plus 1 and y minus 4x equals 1 using both substitution and graphing. We'll notice the first equation here, equation 1, is a quadratic equation, x squared. It's going to graph as a parabola. And here's the linear equation. So we're going to graph a parabola, or we're going to graph a line, and we're going to see if they intersect, and if they do, how many times intersect, and if so, where. Now this one's pretty set up for substitution because equation 1 already says y equals something. So we can just put x squared plus 1 in for y in equation 2, and we have one equation and one unknown. So let's put equation 1, so substitute x squared plus 1 from equation 1, I'll tell you, I'll label these 1 and 2, in for y in equation 2. Okay, so equation 2 says y minus 4x plus 1. Equation 1 tells us what y equals. So we're going to say that if y equals x squared plus 1, I can put x squared plus 1 in for y here. And this is my new equation 2 right there. Now we solve this as a quadratic, so we want to set it equal to 0. So x squared minus 4x, if I subtract 1 from both sides, I have this. Well, there's no constant terms, we can factor the x out. And I have x minus, my factors are x times x minus 4. And so I have two solutions. X is equal to 0 or x is equal to 4. Now, if x is equal to 0, what's y equal to? Well, y equals x squared plus 1, so y equals 1. If x is equal to 4, what's y equal to? Well, 4 squared is 16 plus 1 is 17. Y is equal to 17. Okay, and we can check. This should work in both of them. If I put 0 in for x, out comes 1, which is what y is. If I put 0 in for x, y equals 1. That's my first check. If I put 4 in for x, this is 16 plus 1, 17. If I put 4 in for x, I get y equals 17. So there's my algebraic check. Okay, let's solve it. So this is substitution. Let's solve it graphically. Okay, so let's see here. So there's my substitution. Solution. I'll write down my solution set here. My solution is the 0.01 and the 0.417. Okay, let's solve it graphically. Well, the equation 1 is good. Equation 1 says y equals x squared plus 1. That can go into my calculator. Equation 2 needs to be solved for y. So let's add 4x to both sides, and I have y equals 1 plus 4x, or if you want, 4x plus 1. So y1 equals x squared plus 1, y2 equals 1 plus 4x, and we should come up with these same 2 points where they intersect. I'll shift this up a little bit. Okay, let's get my calculator turned on. Okay, again, let's see, y1 is x squared plus 1. y2 is 1 plus 4x, or 4x plus 1. I'll go to my standard window, which I know is not going to fit because this point here, but we'll start with standard. Here's my parabola, and here's my line. The red is my line, and you can see it intersects. We can see it intersects right there, and that looks pretty clearly like that's the point 0.01. We can do a quick calc on that one for that intersection. Right there, I want it, and it says, yep, so 0,1 is the solution to both. I need to go a bit more in the y direction, so I'll go to my window, and I'll go up higher in the y direction. Whoops, I'll go to 20. Okay, there's my parabola, y equals x squared plus 1. Here comes my line. And now I can see the other intersecting point right here in quadrant 1. Second calc, they intersect. And let's go over near that intersection. There we go. First curve, second curve, guess. And it's the 0.417, which you can see right here. So that's how to solve it graphically. All right, how about example 2? Let's solve this one graphically as well as using elimination. So elimination, as you remember, we want to get rid of one of the, we want to get rid of either the x or the y variable so that we only have one equation and one unknown. Okay, so let's see here. I think, so I'll copy these down here. I'll tell you what, I'll write down first. I'll write it down first. I have elimination. Okay, so we're going to do this with elimination. Okay, so I'm going to write down equation 1. Notice equation 1 is a circle with a radius square root of 13 and a center 0, 0. This is the equation of a circle. Equation 2 is a parabola. Okay, x squared minus y equals -7. It's a quadratic, y equals x squared. Let's see. If I multiply equation 1, notice I have a y squared and a y, so I can't get rid of those. So let's make equation 1 the opposite of x squared, so times -1, so that I can add it to x squared and get a 0. So I have negative x squared minus y squared equals -13, and I will copy equation 2 because it already has a positive x squared here, and I'll subtract y. I'm just going to copy that. Now let's add, and there's my 0. I have no x terms left, or in this case no x squared terms left. Negative y squared plus negative y, that's just negative y squared minus y. And then let's add up these two, and I come up with -20. Okay, so I have a quadratic. So let's set it equal to 0. I'm going to move everything over to the right because I want to get my y squareds positive. So y squared plus y plus 20. Oops, let's make my 20 look a little neater. Equals 0. Can I factor this? Yes, I can. How about plus, whoops, this should be a y. Okay, how about if I do a +5 and a plus 5 and a, oh, it should be minus 20. Made a couple mistakes here. Let me go back and make sure we're okay. I move y squared over to here, I move y over here, so I have y squared plus y minus 20. This is factorable into y plus 5, excuse me, yes, y plus 5 times y minus 4. And so y equals negative 5 or y equals positive 4 are my two possible solutions. So let's take a look here. Well, let's see. I'll put in this first one. I'll use equation 1. So if y is negative 5, this is 25. If I subtract 25 from both sides, this is a negative. I have x squared equals a negative. So this one can't work. Okay, again, I'll do this algebraically. X squared plus negative 5 squared equals 13. X squared plus 25 equals 13. X squared equals negative 12. Not happening. Not happening. Okay, that's not going to happen. Because you can't, in the real number system, we can't take the square root of a negative. Let's try, so negative 5 is not a solution. Let's try 4. And again, let's put it into equation 1 and see what x equals. So x squared plus 4 squared equals 13. X squared plus 16 equals 13. X squared equals negative 3. Again, not happening. So it looks like this is these two. We know this is a circle. Again, we know this one is a circle. And this one is a parabola. So it appears that this circle and this parabola do not intersect anywhere, because the solution of y equals negative 5 and y equals 4, using elimination, didn't come up with x's that worked. So these two appear to not intersect anywhere. Okay, I'm going to put graphically over to the side because I've had another problem down here and I'm out of space. So I'll go over to here. Sorry about that. I'll put graphically over here. Okay, graphically, solve for y. Okay, so I have, here's equation 1, x squared plus y squared equals 13. This gets me to y squared equals 13 minus x squared, which means y is equal to, whoops, I'm making a lot of mistakes today. Y is equal to plus or minus the square root of 13 minus x squared. Okay, there's my y1. Let's do equation 2 here and solve it for y. This one's a whole lot, it's a fair piece simpler. Negative 7. Well, this one is going to be y is equal to x squared plus 7. So here I have my two y equations. I'm going to solve it graphically. And what I found over here is they don't intersect anywhere. Let's see if graphically that shows the same thing. I'm going to slide that up there. Bring in my calculator. Now remember, I've got to have the plus or minus. I need to write this as two different equations, one positive and one negative, to make that circle. I'll clear these out. So I'm going to have y1 be the positive square root of 13 minus x squared. And I'm going to have y2 be the negative square root of 13 minus x squared. I'm just going to graph these two so you can see them. There's the top of the circle, there's the bottom of the circle. Now if I were to go to zoom square, number 5, a bit better circle there. And if I were to go to my window to go from negative 10 to 10 and negative 10 to 10, there you go. There's my circle. So that's equation 1. Equation 1 is a circle. Now this is suggesting equation 2 is a parabola. Let's go back to y equals. And so equation 3, excuse me, is going to be a black line, x squared plus 7. Okay, let's graph that one on there. Well, looky there. They don't intersect at all. The circle is down here, and I'll go to zoom 5. There's the circle down around the origin, and there's the parabola up high. Clearly, they do not intersect at all graphically, and we knew that algebraically because we couldn't get an x and a y. This is never true in the real number system. So this is no solution, and if you recall, no solution means we have an inconsistent system. Okay, let's look at one more, and let's just solve this one graphically. And let's talk a bit more about the whole making sure we get plus or minus in there. Notice again, this is a circle. The center is at 0, 0. The radius is 7. And this one here is a quadratic, so this one here is a parabola. Okay, and so we're going to solve it graphically. We need to set these equal to y. So equation 1, x squared plus y squared is equal to 49. Well, that's going to be y squared is equal to 49 minus x squared. Subtract x squared from both sides, which means we have y is equal to plus or minus, take the square root of both sides, 49 minus x squared. So in this case, y1 equals the square root of the positive square root of 49 minus x squared, and y2 is equal to the negative square root of 49 minus x squared. Now let's do this second equation here. Y squared minus 6x is also equal to 49. Okay, that means y squared is equal to 49 plus 6x. And we have y is equal to plus or minus, because we're square rooting both sides, 49 plus 6x. Okay, so we know we've already used y1 and y2, so we'll have y3 be the positive square root of 49 plus 6x, and we'll have y4 be the negative square root of 49 plus 6x. So we need to graph 4 equations in order to get all these to show up on our graph. Okay, so here we go. Y equals, let's clear these 3 out. Okay, y equals plus or minus, this is a circle. We need to graph it in 2 parts. So we have the positive square root of 49 minus x squared. And we have the negative square, whoops. Come out of here again, let's get the negative, get my square root key, 49 minus x squared. Okay, we already know if we graph that, that's a circle. And there's our circle right there. It's a circle with radius 7, because we know what the equation of a circle looks like, and the center is at 0, 0. That's the first equation right here. It took 2 y equals to graph it, because we have a positive square root and a negative square root. Now let's go back and let's graph this parabola that's also going to require 2 equations, 2y equals a positive 49 plus 6x and a negative square root of 49 plus 6x. Okay, let's graph. Okay, there's that parabola. The parabola opens off to the right. This parabola does. And you can see we have 4 solutions here. We have an intersection point here in quadrant number 2. An intersection point here, it looks like it's on the y-axis. An intersection point here in quadrant number 3. And an intersection point down here that looks like it's on the x-axis. So we want to do our intersect. Second, calculate intersect. Okay, so this one is blue and black. So y1 is the blue. I need to go to the black because I need to make sure I choose my second curve as the black curve. So my second curve is that one, and take a guess. And I see a 0, 7. Negative 1.1 times 10 to the negative 13th is a 0, 7. So 0, 7 is the solution. I'll bet if I go down to here, so second calc intersect, if I go down to here, I'm looking at the red and the pink. Well, Y2 is the red, enter. Now I need the pink, Y4. I need the pink one down here, enter. Take a guess, 0, negative 7. So those are two of the solutions, 0, 7 and 0, negative 7. Now let's go back. I got a solution here again in quadrant 2 right there, black and blue. So second calc intersect. I'll bring my blue one over close to it. Okay, Y1 is the blue curve. Y2 is not the red curve. I want the black curve. There's the black curve, Y3, enter. And I got negative 6 and 3.61. So this point is negative 6, comma 3.61, and that's a rounded approximation. And I want to find the fourth intersection point or an approximation. It's down here in quadrant 3. So second calc, intersect. I'm coming down. The first curve will be the red one. So this is a red-pink intersection. Enter. Not black, but pink. There's the pink. Enter. Take a guess. And negative 6, comma, negative 3.61. So negative 6, comma, negative 3.61. And again, these two are approximations. We're just using our graph to get an approximation. The rest of these look like they're pretty exact. So there you have it. A look at how to solve a system of non-linear equations using elimination, substitution, and graphing.